Okay, here's topic 4 from Unit 3, and we're talking about solving equations that involve absolute value. There's just a couple of key things right here. Just like when we were working with equations with radicals, we had to isolate the radical. We have to do the same thing with absolute value. We need to get the absolute value by itself first. And then we have a method that we use where we then split it into two equations without the absolute value bars, and one where you basically rewrite the equation, and then on the other side you rewrite what was inside the absolute value. So you keep what was inside the absolute value, you flip the sign, which this is more pertains to if we're working with inequalities, and then you change, when I say the sign, I mean the inequality symbol or the equation. And then here when I say change, I mean you change the sign of the number that's on the other side. Okay? You solve and then you check your answer. Let's talk about why you have to have two equations. So you should recall that the absolute value of a number is its distance from 0. So when you talk about the absolute value of 5, so if I'm on the number line here, here's 0. If I'm talking about the number 5 is over here, and the distance that 5 is from 0 is obviously 5. So that's why the absolute value of 5 is 5, because 5 is a distance of 5 units from 0. If I'm at -5, that also is a distance of 5 units from 0. That's why we say the absolute value of -5 is 5. So when you look at an equation like this, the absolute value of x is 5. When we do this, we technically, since the absolute value, like I said, is by itself, you can technically drop the absolute value bars, and you literally rewrite the equation exactly as you see it, and then you say, or you write it again, you drop the absolute value bars, you flip this, but it's an equation, so it's the same on both sides, and then you switch the sign. So that's why if you're talking about some number x whose absolute value is 5, it could be two possibilities. It could be positive 5, or it could be -5, as I'm showing you right here. Those are the two values whose absolute value is 5. All right, let's take a look at an equation. Okay, so on this equation here, the absolute value is already isolated. It's all by itself, so we're ready to just split it into two equations. So we have 2x plus 5 equals 9, or we have 2x plus 5 equals -9. And now we're going to solve them both down. So this would be 2x equals 4. Dividing both sides by 2, you get x is 2. Or, same thing over here, -5. This would give us 2x equals what? -9 minus 5 would be -14. Dividing by 2, you get x is -7. So we're saying we have two solutions, 2 or -7. If you were to plug those back in, what's 2 times 2? 4. 4 plus 5 is 9. What's the absolute value of 9? Does that equal 9? Yes, that one worked. Let's try -7. What's 2 times -7? Well, 2 times -7 is -14. What's -14 plus 5? -9, but what's the absolute value of -9? 9. And that is true. So both of those work. So these are your two solutions. X is 2 or -7. We're probably going to write it like this. Okay. Actually, this should probably be an and. Let's take a look at the next equation. So here we have the absolute value, but we're dividing by 10. So as we said, the first thing we want to do is isolate the absolute value. So in this case, we're going to go ahead and get rid of this division by 10. We're going to do the opposite. So we're going to multiply both sides by 10. These are going to cancel out. This is going to leave us with the absolute value of 9p minus 8 equals 20. All right. And now we have a situation where it's the exact same thing as it was in the first example. So now we're going to go ahead and rewrite 9p minus 8 equals 20. And then we're going to write it 9p minus 8 equals negative 20. Okay? So now we're going to solve both of these. So this would be 9p equals 28. Dividing both sides by 9, we get p equals 28 ninths. Okay, and over here, we're going to add 8. So this is going to give us 9p equals negative 12. Negative 20 plus 8 is negative 12. Dividing both sides by 9, we get p equals, well, negative 12 ninths reduces to what? They're both divisible by 3, so that reduces to negative 4/3. So here's your two solutions. 28 ninths and negative 4/3. Those are your two solutions. All right. And obviously you could plug both of those back in and check your work. Let's go to the last example here. So now this is going to take a couple of steps. Obviously we have the 8 and we have the negative 6 that we need to get rid of, because remember, step 1 is to isolate the absolute value. So the question is, which one are we going to do first? Well, we're going to kind of go backwards in the order of operations. So instead of first multiplying by 6, negative 6, and then whatever that is, and then subtracting that from 8, we're going to work backwards. So the first thing I'm going to do is I'm actually going to get rid of this 8. Whoa, sorry about that. So those cancel out, so I'm left with negative 6 times the absolute value of 10 plus x is equal to, what would that be? Negative 70 minus 8 would be negative 78. The next thing I'm going to do is I'm going to divide both sides by negative 6. Those will cancel out. I'm left with absolute value of 10 plus x is equal to, what is that? Negative 78 divided by negative 6. That actually comes out evenly. That actually comes out to be 13. How about that? All right. Now it's pretty simple, just like the first equation, and now I'm going to go ahead and I'm going to rewrite it now without the absolute value bars. So 10 plus x equals 13, or I would have 10 plus x equals negative 13. This should be pretty easy to solve. We're going to subtract 10. So this gives us x equals 3. This one gives us what? X equals, if I subtract 10 from both sides, negative 23. And let's go ahead and check our solution. So we're saying our solution set is 3 and negative 23. Let's go ahead and check these. So I'm going to plug in 3 here. 10 plus 3 is going to be 13. The absolute value of 13 is 13. So if I do 8 minus 6 times 13, plugging this into my calculator, 8 minus 6 times 13, that gives me negative 70. So that one worked. That's true, because I have my negative 70 there. Let's plug negative 23 in. So we would have 8 minus 6 times the absolute value of 10 plus negative 23 is supposed to give me negative 70. Well, 10 plus negative 23 is negative 13. But the absolute value of negative 13 is 13. And now, negative 6 times 13 is 78. So you would have 8 minus 78 equals negative 70. And 8 minus 78, of course, is negative 70. That's also a true statement. So plugging them both back in, they both work. So that is solving equations with absolute value.